In this program, we're going to look at a C looping construct to sum up a series of values. We will begin with a partial program. We already have the pound includes like we need for every program. For this particular program, I have some unsigned integer values, n, k, sum underscore n, which is initialized to 0. We have a prompt for a user to enter a number between 1 and 1000, the scanf to go along with that, and then a couple of line feeds. We're going to calculate the sum of these integers 1 through n. So whatever the user enters will sum up the values 1 plus 2 plus 3, and so on up to the value n. We have several cases to do, and in the first one, we're just going to label that as case 1 so we can differentiate it from the other cases that we'll do in the following. Let's start with a while loop in order to do this. And let's also just print out the values from 1 to n, and we'll keep n small so that we can see them easily. So if we have a while loop, we will do while k is less than or equal to n, which is the number that's being input. We want to print out the values for k. So we'll just do a simple printf here, double quote, and it's an unsigned integer, so let's use a % for u. And we'll keep them on the same line for a while, comma, and then we'll print out the value for k. And then we need to increment k, so we can use any of our increment approaches. I'll just use k is equal to k plus 1, the simplest one probably. And we'll terminate the loop. I also realize at this point that I haven't given I'm not given k an initial value, so I should do that. So up at the top, let's initialize k equal to 0. Otherwise, we do not know the value of k when we enter the loop. It's not automatically set to 0. Now, let's just go ahead and compile this program and run it, and we'll just generate the numbers on the screen. No summation yet. So we build it. The build has succeeded, so we'll run the program. The output window has appeared, so to keep the amount of numbers on the screen small, I'm just going to pick 20 as numbers. And even that was a little bit too large, perhaps. Can I make this bigger? No, I can't. So anyway, we output to the screen the numbers 0 through 20, and then I should have had a \n at the end of that. Okay, let's make that output look a little nicer. After I generate the numbers, then I need to put a couple of blank lines in there. So let's do a printf, okay, double quote, \n, double quote, right paren, semicolon. So that'll give us some space between the numbers and the message that we need to pause or to hit any key to continue. Now let's build it again. And let's run it again. And this time I only put in 10 numbers to make it fit on the screen. And there you have the output. We'll make that smaller so we can see the loop. So this is nothing very exciting. We just print out the numbers starting k begins with 0, and we add 1 each time we pass through the loop. So we just print out the numbers 0 through 10. Now the sum of these is 0 at this point because we haven't added the line of code that will sum up all these numbers. So now let's do that. The variable that I've declared for the sum, I'm calling sum n, and it's set to 0. Now let's see. Let's put the sum before the print. If you want to sum these up, each time we go through the loop, k is changing. 0, 1, 2, 3, 4, 5. So each pass through the loop, we want to add the value of k to a running sum. The way we do that is we do sum is equal to, and that should be sum underscore n, is equal to the sum underscore n plus the value for k. What this will do is it will take the current value of the sum, which begins with 0. It will add the value of k, and then it will assign that new calculation as the value for sum n. So we are replacing the value of sum n with a new value, which has the value k added on to the previous value of sum n. So that's just a computer science term that's used very frequently, and that's what we're going to use in order to do the summation. All right, now when we finish, we have a print statement already. The sum of the first integers is, and I'm printing out the value for n and the value of the sum of n. Now, let's run the program this time, and we will print out the numbers themselves, and when we're finished, we'll print out the sum. The bill succeeded. When we run the program, I'll enter 10 again to keep it small. And you can see that the output from our loop gives us the numbers on the screen, 0 through 10. Then the sum of the first 10 integers is 55. So this statement at the bottom, this print statement, prints out the sum of the values that we accumulated as we go through the loop. Now, to make this a little bit more obvious, let's change our output so that each time we add a value to sum, we will print out the sum as it grows. So we'll close this, and I'm going to create a small table. All right, so let's go back outside the loop, and let's print some headers for our table. So let's do printf. So let's do a double quote there, and I want to print out the value for k. Okay, so let's put just a couple of spaces and a k. Okay, then let's hit the tab key, put a couple of tabs in there, and let's print out the value of the sum. And then we'll do a \n, double quote, right print, semicolon. So we'll get a header. And inside the loop, I'm going to change my printf statement so that in addition to k, I want to print out the value of the sum of n as it grows. So let's do a %for_u, and let's put a couple of tabs, and another %for_u. This will print out the value of sum as it grows. Then I need to add the variable sum n, sum underscore n, because I'll be printing out the sum as we go along. So this will print the numbers out vertically, and it will give us the values for the sum as we proceed through the loop each time. So I'll build it. Now we can run this. We'll enter the value of 10 once again. And I have all kinds of problems. The formatting is off on this, so let me fix that. The fix that needs to go in here is to put a \n. After I've printed one row of values, I want to go to the next line. So I had failed to put in the \n. Now that's fixed, so we'll build it and try it again. This should look much better. Enter the number of terms. I'll put in 10. And now we do have a table that looks a lot nicer. This time the numbers are printed vertically. So you can see the value of k changes. K goes 0 through 10. And each time we pass through the loop, we print out one row. So the first time through, k is 0, sum is 0. We add them together to get 0. K advances to 1. We add that to our old value of sum. 0 plus 1 just gives us 1. K proceeds to 2. Then, when I add the value of 2 to the previous value for sum, I get the value 3. Okay, K proceeds to 3. We add 3 to the previous value of sum, which was 3, and we get 6. So you can see how this is accumulating the sum as we go along. So each time we increment K, we add the new value of K to the old value of sum, and sum grows. And by the time we have reached 10, we add 10 to our previous value of sum, which is 45, and the final summation value is 55. And so that's what you see on the last line. Let's close this. Now that is pretty straightforward, hopefully. And that sets up what I want to do next, which is to do a calculation of a series of terms that is a little bit more involved. So let's move on to another case and add that in and see how we can work with that. This next case is going to be an addition of some fractional values. To save some time on the video, I have already typed in the information to get us started for case 2. So what we're going to do this time is to use a loop, which instead of counting up or adding up the numbers 1 through n, we're going to calculate the summation of a series of fractions where the denominator is changing by 1 each time. So 1 over 1 plus 1 over 2 plus 1 over 3 and so on up to the value of 1 over n that the person enters. So we'll print out case 2 to the screen and indicating that case 2 is going to be the summation of some fractions. First of all, I need to declare some new variables because if I'm going to add up fractions, an unsigned integer type like sum n is just not going to be suitable. So let's first go back to the top of the program where we declare all variables, and let's declare a float for sum underscore fractions, and let's set that equal to a real 0. Okay, so this time the summation is going to appear in the variable sum fractions. At this point, I could ask the user to type in a different number for the number of terms, but I will just go ahead and use the number that the user entered for case 1 up above. Okay, so we're just going to use the same number of terms, but we'll calculate a different type of sum, which will be the sum of the fractions. All right, so let's make some space here. Now, you can do these summations with any of the 3 loops that we have in the C programming language. In the first case, I showed a while loop to do that. In this case, let's just switch to a for loop just to illustrate the different types of loops. In this case, to use a for loop, I can initialize the value of k here. So let's do for k equals, and I'll start with 1 this time. A fraction that has a denominator of 0 isn't going to work. We can't divide by 0. So for k equals 1, we'll initialize k to 1. And as long as k is less than or equal to the number of terms n, and that needs to be a lowercase k right there. As long as it's less than the number of terms entered, we want to continue, and then we'll do our k plus plus to increment k over there. Then inside the loop, we have a block of code that we need to execute. Now, let's do the same thing we did up above. Instead of just printing the numbers across the page on a single line, let's make a table, and we can watch the value of k change, and we can watch the summation change as we go along. So let's borrow this header that we had up above, where we have print out the headers for k and sum. So I'm just going to make a copy of that line, and I'm going to paste it here before this for loop. So this will just give us another header for case 2, where we have the value of k, but this time we are going to have the sum of the fractions. So let's do sum fractions this time. Okay, now in order to make this work, we need to, first of all, what do we need to do? We need to calculate the sum. We don't need to do the increment for k within the for loop because it's taken care in the header of the for loop up there with the k++. So all we really need in here is to calculate the sum. So in this case, well, we need to print it out, but we'll do sum of the fractions is equal to the old value of the sum of the fractions plus, and here's the key thing, since we want to add up the numbers 1 plus 1/2 plus 1/3 and so on, the numerator is always 1. Okay, so I can do 1, and the denominator is the thing that's changing. So k starts with 1 and goes to 2 and so on. So what I'm adding on is 1 over k each time. Now this is needs to be considered carefully because 1 over k is an integer divide. All right, so I need to make sure that this is a real number when I do the division. Otherwise, I'd get 0. So let's make this 1.0 divided by k. So that will work. Alternately, we could have used the float typecast operator here to change k from an unsigned integer to a float temporarily. So that is the line of code that we need. And whenever you're doing a summation, you always begin with something of this nature. You know, the new value of your summation on the left-hand side of the equal sign is equal to the current value of your summation plus some increment that you're adding on each time. After we calculate that, we will print out the value for k and the value for the sum as we move along. So let's put our printf statement here. Printf, k is still an unsigned integer, so let's do a percent for u will be fine. And let's put the tabs in once again. I'm going to put just well, we'll try 2 tabs, and then we might have to adjust that. Now, the sum of the fractions is a floating point number, so I need a %f of some sort. So let's do a percent. Let's see, the sum of the fractions. Let's make that like a 6.3, and I think that'll be okay. 6.3f \n double quote comma, and we'll print out the value k and the sum of fractions. Right, print semicolon. And I'll take the space out of the loop here. So by using the for loop, I've shortened the body of the loop by 1 statement because I don't have to do the increment for k inside the loop. Outside the loop, I already have a printf statement, which will print out the results. The sum of the fractions is going to be this, and we'll just print out the value for the sum of the fractions. So this will be a little bit redundant because we're doing this inside the loop each time. Normally, however, if you have a large number, if we had, say, 1,000 terms, then we wouldn't really want to see all of those printed out in a table. So we would just have the sum of the fractions printed at the end of the loop and not each time through. But to illustrate how it's working, we'll keep that inside the loop this time. So now we have another case that we can look at. So let's build this version of the program. The bill succeeded. Let's run this. And when I enter the value of, I'll use 10 again. When I enter the value this time, we're going to get 2 outputs. One will be, of course, the sum of the integers from case 1. The other, the sum of the fractions that we just did for case 2. So enter 10. And here's the case 1 table. We've seen that. There's a system pause that is keeping us from getting to case 2. So when I hit another key, then we move on and we see the result from case 2. So let's isolate that and make this smaller. Now, let's look at the output. So there you can see the loop, and here is the table that is showing up in the output window. K begins with 1 and proceeds through 10. And let's think of the way that the summation is being accomplished. Sum begins with a value of 0. Okay, so the first time through, K is 1. So 0 plus 1 over 1 is 1. Sum becomes 1. So that's why we see 1.0 as the first summation. The second pass through the loop, k has advanced by this k++ increment, k becomes 2. When we sum up the fractions, the old value of some fractions is 1. Now k has become 2, so we add 1/2. Okay, so the second pass through the loop, we add 0.5 to our sum, and the sum becomes 1.5. Similarly, when k becomes 3, then we add a third, which is, of course, 0.333 in this case, to the previous sum, making our new sum 1.833. Continuing, we add a fourth. Okay, so after k becomes 4, we add 1/4 to our running sum to get 2.083, and so on. We add a fifth, we add a sixth, a seventh, an eighth, ninth, and finally, the last thing we add is a tenth. So you can see from the summation from term 9, 2.829, if we add 1/10, we get 2.929. So the final sum for this is 2.93 because I'm using a precision of 2 on that last output, so it rounds to 2.93. So that's how you can sum up a series of values that is not just a simple thing like adding up a series of numbers. So here's the for loop that will do that. Now, let's do one more example. And in this example, we'll make our series of numbers yet a little bit more complicated. In case 3, we are going to have a more involved series of terms that we want to add up. So these are going to be the sum of 9 plus 36 plus 99 and so on. And here is the general formula for each term in the series. So if k is the term that's varying, then to compute each term, we have 3 times k times the quantity k squared plus 2. All right, so this is a bit more involved than what we've seen in the first two cases. But let's look at how we can attack this problem. And by looking at this one, then you could set up the summation of most any kind of series, no matter how complicated, that you want. It's just a matter of figuring out what this general equation is for each term. All right, this is case 3. And in order to calculate this summation, I'm going to go get create another variable for this summation. And I'm going to call it just sum of case 3. So let's scroll to the top where in the Microsoft version of C++ or in C, we have to declare everything at the top. So let's declare another float. And I'm going to call it sum underscore case 3. And let's set it equal to 0.0. Now we can go back and write the code to do this. Case 3 is right there. Okay, I am going to go back to the while loop for this example. So to begin with, let's initialize the value for k. So k is going to be equal to 1. And this time, I once again could ask the user to input the number of terms that they want, but I'm just going to use the same number of terms for case 3 that I've used in the previous two cases. So that I will not ask the user to put in a different value here. Alrighty, now let's go into our while loop, and as a first step, instead of doing the summation, let's just see if we can print out these numbers. Let's print out 9, 36, and so on. Just print those to the screen to begin with. Okay, so we'll put the while, and k will be the same as before. K is going to be less than or equal to n, where n is the number of terms that the user wants, whatever that input is. And then we have the block of code. Alright, so the first step is going to be to just print out this value. Now, in this case, I think I want to save each term in a different variable, or I'll use a separate variable here to calculate each term instead of embedding it in the line. So let me come up with a new variable here. So I'm going to call this term value. Well, I'll have to go declare that. So the term value is going to be equal to k, and I will go back and use this equation that I'm showing you here. That's what I want to do. Okay. So the term value is going to be equal to 3 times k, so 3.0 times k, and then in parentheses I want to do the k squared. So I need to put asterisk right there. So all right, 3 times k times the quantity of k squared. I'll use the pow function to do that. Pow of k comma 2 plus 2. And I'll make that a 2.0 because I'm dealing with real numbers here. And a semicolon. Okay, so this will calculate each individual term. All right, first let's go declare term value to be a float. Scroll back to the top. And I will add in here on the same line, comma, term underscore value, and set that equal to 0.0 and put a semicolon. Okay, so now term value is okay, and we have a calculation. First pass, the first thing we'll do is just to print these values to the screen. So let's put our printf here. And let's do double quote, and these are going to be real numbers. I guess it could have been integers in this case, but that's okay. I chose to make these real numbers. So let's do printf Okay, double quote, and let's do a percent 6.1f. Actually, I don't think there'll be any fractional parts, but that's okay. And then we'll keep these on the same line, so it's a double quote, and I'll print out term underscore value, right paren semicolon. Then outside the loop, I want to skip a couple of lines, so we'll print f, double quote, \n, double quote, right paren semicolon. Inside the loop, since this is a while loop, I need to increment k, so let's do k plus plus inside the loop, and that will get the value moving k from 1 up to n. I have a mistype there, it should be a double quote, and I think that does it. So let's build our program. Build succeeded, run the program. Let's type in 10 for the number of terms. There was case 1 that we've done. There's case 2 that we've done. Now, the next output is going to be our numbers from case 3 that we're working on. And I can see already that the numbers are running together, so I didn't make my format quite big enough. But look at case 3, and we'll go back and fix that. Okay, case 3, calculate the sum of 3 times k squared plus 2. So the first value is 9, then 36, then 99, and 216, 405, and so on. But then as the numbers get bigger, they run together on the far right. Right? So anyway, I am printing those numbers to the screen. Now let's go back. And first of all, I want to make that instead of a 6.1f. I have no fractional parts on this, so let's just make that a 6.0. Let's make it say a 7.0. And that should give us enough output space. So I just changed that output specifier a bit. Okay, now we want to calculate the sum of the values as we go through our loop. Okay, so after we've computed a value for the term, then the sum will be pretty easy. And let's do sum case 3 is equal to sum case 3 plus the value of the term value. Okay, so by calculating this term value on a separate line, then this calculation, it's not too big, but it's kind of cumbersome. Then I have isolated the calculation on this line so that when I add the terms down here, this equation now is simpler. Of course, you could replace the term value that I'm using here with the calculation that I've shown up there. That's up to you. Now, to print both values out, we need to print the value for k, and we want to print out the value for the term. Let's do that. So we'll print out the number each time, and then we're going to print out the summation as it grows. All right, so I need 2 real values. So let's do a %7f, and I'll make a table again, tab, tab, and I will do a %7 f.0 again. And then we'll do a \n because now we're making a table. So we'll print out the term value followed by the sum of case 3. Up at the top, let's add a printf, so we'll have a header. So we'll do a printf before we get into the loop. So these will give our columns some header names. So here is our term value, and I'll put a single tab because these headers are kind of long. And then let's write the sum for case 3 as it's growing. Okay, \n, double quote, right paren semicolon. So now we'll be creating a table. And I hope everything's going to align. Okay, so let's build it. That build succeeded. Let's run the program. We'll enter a value of 10 for the terms. There's case 1. There's case 2. And here's case 3. Well, it looks pretty ugly to me. So we have the term value on the left. So you see the terms are going according to the formula. Okay, 9, 36, 99, and so on. Okay, the summation that I'm showing here, I had a problem with the output format. But you can see the numbers are adding up. 9 plus 36 is 45, 99, 245 is 144. So let's go fix this format output because it's really ugly. Okay, so we had percent 7.0f. Okay, a couple of tabs, and a percent 7.0. So I had the 0.0 in the wrong place, so my typing is terrible. So that'll straighten it out. So percent 7.0f in both places. Now let's try this again. Build it. Now let's run the program. 10 is a good number. We'll stick with it. There's case 1. There's case 2. Here's case 3, which looks a lot better now. So let's scroll to remove the other case outputs. So there we have it. Here's case 3. So this loop, as it's moving through, the first value is 9, and then we go to 36, and so on. So by the time we reach 10, then our number is 3060. You can see that we're accumulating the sum as we go through the loop. So the first time through, 0 plus 9 is 9. 9 plus 36 becomes 45. The next pass through the loop, third pass through, our term value goes to 99. We add that to our running sum to get 144, and so on down the line. By the time we have accumulated all 10 terms, then our sum has gone to 9,405. So this is it. This is the way that you would handle calculating a series of values. And in mathematics, engineering, physics, chemistry, and so on, you run into this kind of thing on a consistent basis. It's a frequent case where you can calculate an integral or things of that nature by expanding it into a series as we see here. So given these examples now, you should be prepared and able to accumulate a sum of values using this technique and any of the loops that are available to you. So that concludes this video.